All right, today we have the second last lesson of stuff. So, the last section of the probability and statistics is to do with sampling and estimation. So a few definitions. So first of all, population. So population is everyone in the group.
Whoever thought psychology would help me in mathematics.
Well, there you go.
I thought that subject was completely useless, but here we go.
Alright, so population's everyone in the group, depends on what that group is as to what population it is. So if the group is Wangaratta High School students, then it's just the students, the population is just the students within this school. If it's to do with Victoria, then it's everyone in Victoria. If it's Australia, it's everyone in Australia. Alright, so a sample. A sample is part of the group, so it's part of the population. And ultimately what we want is a random sample. Right, so say for example, if we want a sample from the students at this school, then we need to take it randomly, not just go to 10A and ask them and have 10A being representative of the whole school. We need to take random numbers. All right. The next thing we're looking at is what's called the population proportion. So the population proportion, we use P to represent that. So that's what proportion of the population have a particular thing, blue eyes or whatever it might be. So for the population proportion, we need to know the number in the population with that particular trait. Whatever that might be. And over the population size. Alright, so for population proportion, you have to ask everybody. And the other thing about population proportion, the value of it is constant. Alright, so because you've asked everybody in the population, then that stays constant, doesn't change. The sample proportion, however, may change depending on the random sample and who's in it. Right, so, and that's what we're going to look at. Sample proportion. All right, sample proportion. So the symbol we use for sample proportion is the P. And I put a little hat over the top of it. All right, so the little hat relates to the sample. So with this stuff, any of this stuff that has a hat on it means sample. All right, so we need to know the number in the sample with the trait. Over the sample size. All right, and as I already mentioned, the value of this may vary from sample to sample. Now, the other thing I haven't done, I haven't put the symbols on this. X over, not again, little n, is what we use, and this is on your formula sheet. There's the symbols that are used on the formula sheet. So X over n, X as being the number that you've got, n being your sample size.
So is it the same for population proportion?
May or may not be, depending on your sample. Alright, so for example, if the population proportion of blue eyes is 0.4, depends on your sample that you've chosen, whether you get 0.4 or whether you get something that's close to 0.4. And then again, if you choose a different sample, you may get a different result. Alright. So let's have a look at an example.
Who cares? It's a book. It's my book. Get your own damn book and write your name in the name section. Stuff you in the room.
That's a weird argument.
So here we've got a bag containing 6 blue and 4 red balls. If we take a random sample of 4 balls, what is the probability of 1 blue ball in the sample? so we need to know a few things. We need to know well, the sample size is 4 and the number in the sample is 1, so the sample proportion would be 1/4. But what we need to do is see whether or not that sample proportion actually relates well to what we've got. So what have we got? We've got 10 balls altogether and we're selecting a sample of 4. So we're selecting
This is okay.
Sorry.
4 balls from 10. So if we're selecting 4 from 10,
You should
That's-
never tell someone who's coughing to shut up.
10C4.
Nicole's very sensitive about this stuff.
Stop making yeah. I am.
Alright, so we're selecting 4 from 10. So there's 210 ways we could do that.
Really written.
Alright, so there's 210 different ways we could take 4 balls out.
Had you already done?
Do you just look at that and go, oh,
Yeah,
that's going
one I
on there?
prepared with earlier.
How
Sorry.
are we supposed to know that?
I forgot.
It's just
I
demonstrate.
forgot to say from one I prepared earlier. Sorry, I forgot to say that.
What's this?
Do apologise. You would
Yeah,
do
what's
that
the
on your
C?
calculator, and because I prepared it earlier, it's 210.
What's the C?
Is that how you?
Combination.
It's on the calculator.
So if we are selecting, so when we're selecting, we use the C, NCR on your calculator.
One in advance.
Oh, cool.
210, correct?
No.
All right. What do we want? What we want is we want 1 blue ball and
3 red.
3 red. Now, whenever we see the word "and," the word "and" means
Necessary.
As
as well as, and in terms of
oh,
our mathematics, what do?
also including.
Given that.
What is
Oh,
it?
does it have a line underneath?
Not a line underneath. We want that and that. This as well as
Oh,
this.
that undercurve thing.
Not the undercurve
The
thing.
overcurve thing. Oh, the X.
Time.
That was my next guess.
If you weren't reading in these, and the wording for the probability questions is important. Right, the word "and." Let me write it up over here. Somewhere.
Write it up in pink, simple.
So "and" means we multiply. If it says "or," it means we
Divide. Oh.
Alright. So when you're doing probability, the word "and," you automatically think, oh, I've got something I'm going to multiply. If it says this or this, then we've got something that we're going to add. For "and," we want them both at the same time.
Is there a
For
take-
"or," we just want one at any time.
Is there a takeaway in the division?
No, there is no takeaway in the
Doesn't that
division.
mean it would be plus for and times for all?
Do you want the
That's what I just said. Times for "and" plus for "all."
No, wouldn't it be the other way around?
No, it's
Yeah, one or the other, the probability that add up to one. Like, the times thing it's probability is multiplied.
Okay.
You do both. Because they're both.
It means NCR on the calculator.
No,
Now-
10C4 means.
Yeah, NCR on the calculator.
Is that put in the bracket?
So here we're wanting 1 blue from 6 and 3 reds from 4. So how many ways can we get that? Well, we can get 6 above 1, so 6C1. We've got 6 balls, how many ways can we get 1? And means multiply. We've got 4 red and we want 3. How many ways can we do that? And when you because I've prepared it earlier,
Thanks.
it's 6 times 4, which is 24. So if we're now looking at the probability that our proportion, as we're asked for a probability of one blue ball in the sample, so probability of one blue ball in the sample means we're looking for a sample proportion to be 1/4. So what is the probability that our sample proportion is equal to 1/4? How many ways can we get one blue ball? Well, we found we can get 24 ways we can get one blue ball out of the 210 ways we can select 4. And then you can cancel that down. 6 goes into the top and the bottom, and you end up with 4/35. So in our sample we want 1 out of the 4. If we do this lots of times, we would find 4 out of 35. If we did it lots of times, 4 out of every 35 times, we would get 1 blue ball in the sample. Yes, Lara?
What's the little P with the hat?
P with the hat is the sample proportion. So we're taking a sample. We want 1 blue ball in that sample of 4. So the sample proportion we're looking for is 1/4, and there's 4/35 probability of
Is there,
getting that.
is there a little symbol for the population?
The population has got no hat.
So, you're taking a sample of 4 balls and you want 1 to be blue. So,
Oh, okay, so it's
So the sample proportion we're looking for is 1/4.
so X is 1 and the N is.
Sample proportion we're looking for is 1/4. What's the probability of us getting that? The probability of us getting that is 4/35.
Oh, no.
Right.
No, wouldn't it be a first? No, because the other one has for all of
Now, of course, that's just one option out of that 4, where we get 1 blue ball. We could get none, we could get 2, we could get 3, we could get 4. And so often you will get what's called a sampling distribution, which includes all of that stuff. So let's have a look at what the distribution for that example would be.
How did you get to 3 red from 4?
Because there's 6 blue and 4 red balls.
And we want to get 1 blue ball, so the rest.
We want to get 1 blue ball in our sample of 4, so as Nicole said, the other 3 have got to be red. Alright, because it says probability of 1 blue ball in the sample. There's 4 in the sample, we wanted 1 blue, there's 3 more, they've got to be red. If they're not, then it's not what we're looking for.
Yeah.
Alright. So, if we look at the other possibilities, I'm continuing with this here. So if we look at the other possible outcomes, so the number of blue in the sample and so the number of blue in the sample, there could be none. 1, which is the one we've just looked at. 2, 3, 4, 4. 4 could be. So there's a couple of things that we can put. So what are we looking at? So if we're looking at the sample proportion, for example, So the proportion of blue balls in the sample, this one of course is 0. This is the one we've just looked at, 1/4. The next one here would be 2/4, which is a half, 3/4, and then the sample proportion there would be 1. Probabilities of each of those occurring, now we've already worked out this one here, which is that one, 4/35, so if you follow the same kind of process, alright, all you need to do is this step here you need to change. So for this, when you've got no balls in the, you change that to a 0 and that to a 4. Right. To work that one out. So we've got no blue and 4 red. Let me get rid of this so we don't confuse. So if we're working out probability of this, of none, that's what we would have to calculate and put on the top. When you calculate that, works out to that. If we wanted to know the probability of getting 2 blue balls, then 2 changes. And so you get 90/210. May cancel down, but I haven't bothered with that. 3 blue balls, we change this in our calculation. And when we work that out, you get 80/210. And the last one is when you've got 4 blue balls, changes to this. And when you work that out, you get 18/210. And so what are these probabilities? These probabilities are probabilities that the sample proportion equals whatever that is there. So big P and little p. All right, so for example, find the probability.
Is this another?
It's continued, e.g. continued. It's continued from the stuff we've just done. All right, so it's still our same blue and red balls, 10 blue and red balls. So what do we want to do? So find the probability, determine probability that the proportion of blue balls in a sample of 4 is greater than 1/4. All right, what does that mean? So writing that in words, probability that the proportion, so probability that the proportion of blue balls in the sample is greater than 1/4. So So when we look at our table, here's our sample proportion. There it is 1/4. We were looking at the sample proportion being bigger than that. So half is bigger, 3/4 is bigger, and 1 is bigger. So we're actually after the probability that the sample proportion is equal to half, or
Plus.
sample proportion being equal to 3/4, or the sample proportion being equal to 1. Right, so it's either 2 blue in the sample, or 3, or 4. And you just read those numbers there, add them up. So it's 90 over 210, plus 80 over 210, plus 18 over 210. And when you add all of that up and cancel, as I have prepared earlier, you get 37 over 42. So looking at that, there's a pretty good chance that you're going to get more than one ball in your sample. Okay. Right, the last thing is about means and standard deviations of our samples. All right, so if you want the explanation or the proof, then you can go to your text. Pages 697 and 698. But you don't have to reproduce those, just have to use them. So, our mean. So the expected value of our sample proportion is simply the population proportion. So if we take lots of samples, their proportion may be slightly different to the population proportion, but the expected value would actually be the population proportion. We would expect that that's what we're going to get. We may get slightly different. We do it lots and lots and lots and lots of times. Put all those things together, then it would average out to the population. The standard deviation, which for this is the symbol that's used. We don't use the little sigma when we're talking about proportions. We use SD with the P, so standard deviation of your sample proportion. All right, very similar to what we had before. So it's the population proportion. 1 minus the population proportion, but this time we divide it by n, the number in our sample, and of course we then square root. Now this is given a name, so this is referred to, can't spell, standard error of the sample. So when you read standard error, they're talking about the standard deviation of our proportion, sample proportion. Remember, standard deviation is about spread out from the mean, how much spread out from the mean is. And remember, we're wanting ultimately our mean of our samples to be as close to the population proportion as possible. So you take a sample and you get one that's a little bit different, that's why they refer to this as the standard error. So it's like it's the error in your sample compared to the population. All right, an example, and then we're done. So I'm going to use example number 9 in your textbook, page 699. Alright, it says, suppose that 70% of 17-year-olds in Australia attend school. If a random sample size of 20 is chosen from this population, fine. Alright, so in that there's a couple of things that they're telling you. They're telling you 70% of 17-year-olds in Australia, and then later on in that next sentence, right at the end, they say from this population. So this population they're talking about is the 17-year-olds attending school. All right. So in our population, our proportion in our population is 70%, which is 0.7. Right, that's how many at school. Our sample, well, we're told, it's a random sample of size 20, so we know n is 20. All right. Have a look then. So what sort of probability do you think we're looking at here?
What's the question again?
All right, what sort of population, what sort of probability are we looking at? So are we looking at normal probability, we're looking at binomial, what are we looking at? Well, to find that out, we need to look again, read this. Suppose that 70% of 17-year-olds in Australia attend school. So 70%, this port refers to attending school. What other options are there? Not attending school. So how many things are there? 2.
Binomial.
So binomial, yep. Alright, so we're going to use binomial probability to help us. Alright, in part A. It says, what if the sample proportion is 0.7? Sorry, I'm reading the solution. Probability that the sample proportion is equal to the population proportion. All right, so what's the probability that the sample proportion is equal to the population proportion? So in our sample of 20, what's the probability that 0.7 of those 20 will attend school. That's what we're thinking. Attend school. All right. So, what do we need to do? What we need to do is we need to find out how many ways from our samples we can get that. So, if we're after 0.7, then how many students is that?
14 over 20.
Yep, 14 over 20. So, another way, 20 times 0.7, which is our 14. So it's 14 out of the 20, exactly. The next question is, how many ways can we make our selection, or from our selection, sorry, how many ways from our sample of 20 can we get 14? So, how many ways? All right, so how many ways can we get 14? Again, that's, we've got 20. And we want 14 of those 20 to get, I'll be attending school, I should say, not get. Of those 20, how many different ways are there that we could have 14 attend at school?
The number that you prepared earlier.
Hey?
The number that you prepared.
Prepared earlier, yep, that's right. Now, if we're using binomial, binomial is talking about probability of success and failure. Success in this case is?
Being a student.
Yep. Is attending school. And so the probability of that is 0.7, and we've got 14 that are attending school. Then our failure is 0.3, and if there's 14 attending, there's 6 not. And then, yes, one I prepared earlier
Or the text.
on the calculator, you get 0.1916. All right, so it's about 19% chance of a random sample of 20 17-year-olds in Australia. You'd have 14 of those that attend school. Part B says the probability that the sample portion lies within one standard deviation. All right. So we want the probability that the sample portion is the mean plus or minus one standard deviation.
Is that part B?
This is part B. I forgot to write my B. Yep, sorry. So the probability that the sample proportion is one standard deviation of the population proportion. All right, so let's have a look. So the mean, which is the population proportion, and before is 0.7. Standard deviation of our sample. Right, remember that is the square root of n, not p, thinking the wrong one. P, 1 minus p over n. So it's the square root of 0.7, 1 minus 0.7 over 20. And because I've prepared one earlier, you get 0.1025. So, what are we now looking at? So let's look at this again. So we want the probability that the sample proportion is the mean minus 1 standard deviation. I'll leave myself enough room. And the mean plus 1 standard deviation. Let's put the numbers in then. So that is the probability that our sample proportion, the mean is 0.7 minus 0.1025 less than 0.7 plus. Probability, put the numbers in, work that out as I've prepared earlier. 5975. What's that? 8. All right. So now, what could we use to help us? Any ideas what we might use to help us?
Calculator.
The calculator? We will.
What's the third number of the, your one is 59 what 5?
7.
7.5. We are going to use our calculator, but first, before we use our calculator, we need to adjust this. All right, because at the moment we've got the population proportion, and we need to adjust this to actually numbers in our population. All right, so now, excuse me, now we need to change from proportion to numbers, to actual numbers, in our population.
They do this on a long calculator.
No, they would not, because you need to be able to.
Unless you're a human calculator.
Yeah. So when we change that to actual numbers, that's 0.5975 times 20, which is our population, which is our sample. And so if we're changing from actual numbers, we now change this symbol to X. All right, so that's the proportion in terms of, 1/4, 1/2, or in this case, 0.5975. We're actually changing to actual numbers, so we change that to an X. Now we've got actual numbers. And because I've worked this out earlier, you get 11.95 and 16.05. Now, anyone see anything about these numbers? together, but that's not what we're looking at.
They're not a whole person.
They're not a whole person, yes.
As in like another.
Because then you can't have 0.05 of a person.
I can't just chop
Like
some.
someone's 2 legs chopped
Yeah,
off,
okay,
and he's still
that
a
makes sense.
person.
I thought this was like some last step.
Because we're talking about a sample of people, aren't we? So you can't have fractions of people, you can only have whole people.
Can't have fractions.
So what we need to do is change those to the nearest whole person, so between 12 and 16. Then what sort of probability might we use there? Or what will we use? We'll use our calculator. And so when we do that in our calculator, and what sort of probability have we used?
Oh,
Binomial, yes. So we were looking for binomial.
we were already in binomial.
Yeah. I'm just reminding.
That sounded like we might have suddenly switched.
No. I'm just reminding people that they haven't forgotten that we've been using binomial.
Like, so say.
Because you've got various options in your calculator as what sort of thing to use, haven't you? So make sure you use the same one.
Is CDF when it equals?
CDF is not when it equals, PDF when it equals. CDF is cumulative, so it's when you want a range of stuff. And here we're after a range of stuff, aren't we? Between 12 and 16. So we're after a range of stuff. We need CDF. And when you do that on your calculator, because I've prepared one earlier, 7796, I hope. Oh, the last bit. Probability sample proportion lies within two standard deviations of the population performance. What's the difference between part C and this?
You just multiply it by 2, the sample.
This bit here is multiplied by 2, yes. So this was between one standard deviation. We're now wanting for part C between 2 standard deviations.
That makes me upset.
All right.
Not even worth writing down.
So when we do that, then I'll shortcut that a little bit. So 2 standard deviations below. Two standard deviations above. When we figure that out, that's 0.7 minus 2 times the 0.1025, I should say. Which when you work that out comes to 0.495 and 0.905. Oops, too many decimal points. When we change that then to numbers, we're looking for the probability that in our sample we've got between 9.9 people and 18.1 people. We can't have parts of people, so we need to take it to the nearest whole person. So we're looking between 10 and 18 persons. We do our binomial CDF again. And we get 0.9752. Which is a little bit more than what our rule of thumb says, but it's not too bad. And that's more to do with the sample size than anything. It's only sample size of 20, a massive sample size. All right, 17A and B, that's it.
Oh, 17.
Yeah.
Oh, God.
Which actually goes to
Next
Not-
Tuesday we'll
not
do
17.
C and D and then we're done.